Good morning, one and all. So today's session it is based on problem solving on types of systems. So yesterday we have seen various types of systems. Okay, welcome to this particular session on problem solving on types of systems. So we'll see various problems on systems, how to solve that problems. Yesterday we have seen various types of systems and we have explained that one by one. So that systems like we have discussed static dynamic system, we have discussed causal non-causal system, we have discussed linear non-linear system, and we have discussed stable unstable system, as well as time variant and invariant system. So we will begin with today's session with stable and unstable system. Unstable system. So yesterday we have discussed about stable and unstable system, but we have not discussed how to solve that particular unstable system. We have not seen how to solve the problems on stable or unstable system. The system will be called as stable if for bounded input we are getting for bounded input we are getting output as a bounded output, that is called as bounded output. So that is called a stable system. This is for stable system. And if we are providing bounded input and we are not getting the bounded, means unbounded output, so that is called as unstable system. Now how to check whether the system is means stable or unstable? See, for stability of the system, the condition is summation n start from minus infinity h of n should be less than infinity. Means the impulse response of the system over the time from minus infinity to infinity must be, the magnitude of that impulse response must be less than infinity. So that is nothing but condition for stability. And using that particular equation, using that particular thing, you can calculate whether the system is stable or unstable. Now I will show you how you can calculate whether the system is stable or unstable We will take example. If suppose y of n is equal to n x of n minus 1. So yesterday's problem, y of n is equal to n x of n minus 1. This is the equation given of the system. This is the equation, and we have to check this particular system is stable system or whether it is unstable system. So that is our today's task. Suppose y of n is equal to n x of n. First of all, what you have to do, you have to replace x of n by delta of n, means it is impulse response, so that this equation will become h of n is equal to n into delta of n minus 1. Correct? You have to replace x of n by delta n, means input will be delta n. Input will be delta n, means it is impulse. If you apply impulse as an input to the system, that will be called as impulse response. So h of n is equal to n into delta of n minus 1. Now find out n start from minus infinity to infinity. So you can put n is equal to 0. What is the output of the system? H of 0 is equal to 0 into delta of minus 1. So it is equal to 0. Put n is equal to 1. H of 1 is equal to what? 1 into minus 1. It is equal to 1 into delta of 0. We know that delta of 0 value is only 1. So it is equal to 1. Impulse signal, we know impulse signal at 0th location only the signal having value 1 and all other are equal to 0. So it is nothing but delta of n. Now you can put for n is equal to 2, place n is equal to 2, h of 2 is equal to 2 into delta of 2 minus 1, means 1. So what is the value of delta of 1? It is 0. So it is 0. Means if you put all the values of n till for positive infinity, the values will come to 0. If you go for n is equal to minus 1, then h of minus 1 is equal to minus 1 into delta of this minus 1 minus 1 minus 2. So answer is equal to also 0 because there is no value for delta. So it is 0. Now write down this equation. Summation n start from minus infinity to infinity. H of n is equal to 0 plus 0 plus 1 plus 0 plus 0. So answer is equal to 1. So which is less than infinity. This is less than infinity. Hence this system is stable. So this system equation y of n is equal to n x of n minus 1 is stable system. Stable system. So yesterday we have solved various things on it. Those are the things we have checked it for it. We have checked it for static dynamic. It is dynamic system. This system is causal system. This system is linear system. This system is time variant system, and this is stable system. So this is nothing but how we can check the system is whether it is stable, unstable, time variant, invariant, linear, non-linear, causal, non-causal, dynamic, static, dynamic, etc. I will solve some other problem on it. We'll take some other example. Suppose system is, you have to check all those, means whether it is causal, non-causal, whether it is linear, non-linear and all. So for y of n is equal to e raised to x of n. Suppose the equation is given, system equation is given as this is the system equation. Now what you have to do, you have to check whether system is first static dynamic or dynamic. Second, you have to check for causal, non-causal. Then third, you have to check for whether it is linear, non-linear, linear or non-linear. Fourth is check, you have to time variant, invariant. And last, it is stable or unstable. Now we'll begin with the solution. First point, static dynamic or dynamic. Now what is the equation given? Y of n is equal to e raised to x of n, right? This is the equation given. Now put n is equal to 0. So what is y of 0 is equal to e raised to x of 0. Put n is equal to 1. So it is y of 1 is equal to e raised to x of 1. Means see, for input, current input, means for current output it is depend on current input only. Means for at 0th location, 0 value, the output comes as a y of 0. So this system is static system. So y of n is equal to e raised to x of n is static system. Static system. This is static system. Then second bit. Second, we have to check for causal or non-causal. Causal or non-causal. What is the equation? Y of n is equal to e raised to x of n. Y of n is equal to e raised to x of n. Then n is equal to 0. So y of 0 is equal to e raised to x of 0. For n is equal to 1, y of 1 is equal to e raised to x of 1. From this, what we have concluded that output depends on present input only. So in this case, output of the system depends on present input only. Hence y of n is equal to e raised to x of n is causal system. For static also you must write this, that the output of the system depends on present input only, hence it is static system. So you must write it. Output of system depends on present input only. Hence this system is static system. You must write those sentences. Now we'll go for the linearity. Third is linear, non-linear. Linear or non-linear. What is the equation? Y of n is equal to e raised to x of n. Now let x1 of n and x2 of n are two inputs. Now for x1 of n, what is the output? y1 of n is equal to e raised to x1 of n. This is for x1 of n. Now for x2 of n, what is the output? y2 of n is equal to e raised to x2 of n, correct? Now find out, apply. So you have to apply a1 x1 of n apply a1 x1 of n plus a2 x2 of n to the system. Then output is y3 of n is equal to, what will be the output? Whatever input you are giving, that will become e raised to a1 x1 of n plus a2 x2 of n, correct? So this is the output after applying this one. Now what you have to do, find out y3 dash of n, that is nothing but a1 y1 of n plus a2 y2 of n. So is equal to a1 e raised to x1 of n plus a2 e raised to x2 of n. This is equation number 2, equation number 1. Now compare both the equations. Here whole quantity is e raised to something, but in this case a1 is multiplied to e. So those equations are not equal. So y3 of n is not equal to y3 dash of n. Hence system y of n is equal to e raised to x of n is non-linear system. Non-linear system. You must solve it very carefully, how that system will be, whether it is linear, non-linear, and it is easy to find, but follow the same procedure for linearity, non-linearity. Then we'll go for next, fourth. That is what? Time variant, invariant. Time variant or invariant. Now what you have to do, what is the equation? Y of n is equal to e raised to x of n, correct? Now first of all, delay input x of n by k units. So that is nothing but x of n minus k, and apply it to system, so that y of n comma k is equal to e raised to x of n minus k. Equation number 1. Now what we have to do now, replace n by n minus k from the equation of this equation. Y of n is equal to this one, so that it is y of n minus k is equal to e raised to x of n minus k. Equation number 2. Now compare both the equations, this one and this one, both are equal, means here y of n comma k is equal to y of n minus k. Hence system y of n is equal to e raised to x of n is what type of system? Time invariant. Invariant means it is not changing with time. See, it is not changing with time. Even if you delay input, even if you delay output, then it is not changing. So this system is called as time invariant system. And then fifth type of the system is stable and unstable. Now in stability condition, y of n is equal to what? E raised to x of n. What you have to do? You have to replace x of n by delta n. So it will become h of n is equal to e raised to delta of n. Correct? Now what is the condition for stability? Condition for stability is summation n start from minus infinity h of n is must be less than infinity. Now start solving it. Put n is equal to 0. See, you can take it. Now put n is equal to 0. So what will happen? H of 0 so this h of 0 is equal to what? E raised to delta of 0. So what is the delta of 0? E raised to 1. So it is equal to E, means 2 point something 73, like this. Then for n is equal to 1, h of 1 is equal to e raised to delta of 1. Delta of 1 is value 0, so e raised to 0. So any value raised to 0 is 1. If you put any value 2, h of 2 is equal to e raised to delta of 2 is equal to e raised to 0 is equal to 1. Means for delta of n, all the values are 0 except at location 0, the value is 1. Means you will get e value for everywhere. You will get everywhere e value. Means if you calculate this summation n star from minus infinity infinity h of n is equal to, you will get dot 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 1 plus 1 plus 1 plus so on e raised to 1 plus 1 plus 1 plus till infinity. So this value is infinity. The value is infinity. Hence system y of n is equal to e raised to x of n is unstable system. Unstable system. Why it is so? Because you are getting values. Means see, delta means it is the value at location 0 and all other values are 0. Means e raised to 0 you will get everywhere. So e raised to 0 means 1 from positive infinity to negative infinity. Hence the system is unstable. Now we'll write it for y of n is equal to e raised to x of n. This system is static system. This system is causal system. Then this system is non-linear system. This system is what type of? Time invariant system. This is causal. Then it is non-linear. This is time invariant. And last it is unstable. So you can solve it for any system equation by following the rules, by following the procedure as we have followed. Here you can see, if the equation y of n is taken, y of n is equal to e raised to x of n, what you have to do in static, you have to put n is equal to 0, n is equal to 1 and check whether the output is depend on present input only, then it will be static. If not, then it is dynamic. In case of causal system, you have to put n is equal to 0, n is equal to 1 and check whether this system is depend on present, past, future, such type of inputs. In this case, it is depend on present input only. Hence, y of n is causal system. Now, then go for linear or non-linear system. Apply two inputs, x1 of n and x2 of n. After applying two inputs, find out the output y1 of n and y2 of n. Then apply the combined input by multiplying a1 to the input 1 and a to the input 2. So I'll find out the output and check whether both are equal. If not equal, then that is non-linear system. If both are equal, then it is linear system. Then in fourth case, time variant or invariant. First of all, delay the inputs by k units. Then apply it to the system, find out the output. Then go for replacing n by n minus k from the original equation. If both are equal, then it is time invariant. And if not equal, then it is time variant. And in case of stability condition, replace x of n by delta n because we are finding impulse response. Then put 0, 1, 2, 3 according to calculation and calculate this summation. Start from n is equal to minus infinity h of n. And if it is infinity, then that is unstable system. If it is less than infinity, that is called a stable system. So we have solved for this y of n is equal to e raised to x of n, and we found that it is static, causal, non-linear, unstable and time invariant type of system. So this is very important question. So you can prepare for this types of systems. Now we'll stop here. Thank you.